Hi, I'm Casey from Skynet. There has been a lot of talk lately about accessing operations technology, OT data, in IT. Timely access to information can help with production planning, resource management, safety monitoring, AI, and fault prediction. And routing this data to cloud services opens more possibilities. Enterprise-wide analytics, monitoring, reporting, and aggregation of multiple sites. You can even share subsets of your data with third-party suppliers and customers. However, there are challenges in accessing OT data from IT. We identify three areas: availability, security, and reliability. Availability means providing data to any user who needs it, when it is needed, in a form they can use. Security means restricting availability to only authorized users. It's an inverse relationship. The more secure the data is, the less available it becomes, and vice versa. Reliability means preserving the data and making it available, even in the event of a hardware, software, or network failure. Let's look first at security. What are the best practices for OT to IT data connections? Most important, OT must be completely segregated from IT. Treat them as hostile to each other. A compromise of one should not compromise the other. Keep all inbound firewall ports closed to data connections and use a DMZ to segregate networks. IT networks are more likely to be entry points for attacks and should be strictly isolated from OT. Second, OT should not be connected to the internet in any way, only to a DMZ. That means no direct or indirect internet connections, no proxies, and no VPNs. Again, all inbound firewall ports must stay closed to the data connections. Restrict data access to only authorized and authenticated parties and ensure there are no leaks or intrusions from the user back to the source in OT. Take precautions with what data does go out. Expose only what is necessary. Upstream users don't need access to every variable. Don't give access to the whole server dataset. And finally, if you are sending data back to OT or doing any kind of closed-loop control, make sure you have a way to regulate volumes and check the quality of incoming data before using it. The other main challenge is reliability. Reliability means preserving connectivity and keeping data consistent across the system in an event of a hardware, software, or network failure. As much as possible, the most recent value of each data point must be available to all clients at all times. Creating redundant networks with hot standby makes your system more resilient to connection failures. Redundancy means establishing two identical data paths on different networks and switching from one to the other if the first one drops. Also, you can use store and forward tools to build a data history so that if a connection drops, the data is collected and then forwarded along when the connection is restored. Keep in mind, of course, that historical data should be clearly distinguished or separated from real-time process data. One of the challenges in designing for reliability, security, and accessibility for OT data is that attempting to balance these three may narrow your choice of data protocol. This challenge is compounded by the fact that all of the major protocols currently in use were designed before 2006. None of them was specifically built for Industry 4.0, IoT, or for securely connecting OT to IT. Each has its strengths and weaknesses for such applications. Let's look at the four main OT protocols. For OPC, there is OPC Classic and OPC UA. OPC Classic includes OPC-DA, A&E, and HDA. OPC Classic is a solid standard. It is fast, robust, and has a large installed base. However, it is only available for Windows. It has poor security model, and it uses DCOM for networking, which is difficult to configure and not very secure. OPC UA, on the other hand, has much better security and networking. It runs on many OSs, Windows, Linux, and more. It can be built into PLCs and is extremely flexible. However, it is quite complex, and it requires opening a firewall port to access data. OPC was designed for in-plant applications and performs well in that environment. For communications outside the plant, more and more people are turning to MQTT. MQTT was designed as a simple communications protocol for connecting field devices to a central server. It is a good edge protocol, and it has the advantage of connecting outbound from the OT side, keeping all inbound firewall ports closed. But MQTT is simplistic. It does not define a message structure, so there is no interoperability. It is not suitable as a backbone protocol for OT to IT or IoT, and it can fail under a large load. MQTT Sparkplug was built on MQTT and has the same advantages while also providing interoperability and a presence mechanism. So it is more useful for OT to IT applications. However, it still inherits some of the limitations of MQTT that can cause issues under load. In addition, Sparkplug has not yet achieved wide industry support, and the specification is in flux. To sum up, OPC Classic, that is OPCDA, ANE, and HDA, are good for backward compatibility, local connections, and trusted networks. OPC UA is good for cross-platform connectivity, data modeling, embedded servers, and partially trusted networks. MQTT and Sparkplug are good for edge collection from low bandwidth devices and other simple topologies. Non-trivial communication solutions typically use a mix of protocols to meet the goals of accessibility, security, and reliability. So what is the best way to combine these protocols and build the most reliable and secure system? Skynet addresses these challenges, follows best practices, and employs the appropriate protocols to provide secure and reliable access to your operational data. Our Cogent DataHub software supports multiple protocols, gaining the strength of each by connecting OPC Classic, UA, MQTT, and more, and integrating them seamlessly. For network security, DataHub software provides full DMZ support, passing connections securely through DMZs over multiple node hops at low latencies, isolating OT networks from IT and cloud services. The data connection is done with tunnel mirroring, which keeps all inbound firewall ports closed on the OT side for any connecting protocol. To bolster MQTT, the DataHub Smart MQTT broker aggregates, standardizes, and secures MQTT data, with full integration and support for Sparkplug. It responds to errors, resolves failed writes, and adds data quality information. For reliability, all supported protocols are available in redundant configurations, allowing you to switch between two or more identical data paths. DataHub software supports store and forwarding for historical and database connections, storing data during outages and forwarding it when it's reconnected. The software also provides a unified namespace where participating programs exchange data through a single unified dataset. Secure design exposes only the data meant for each connecting client. And finally, to move data seamlessly from OT or IT to the cloud, you can configure MQTT or tunnel connections from a DMZ or IT to any cloud service. Using Cogent DataHub service for Azure on the Azure Marketplace allows you to securely acquire, monitor, control, consolidate, and share your live process data from there. Yes, there are challenges when connecting OT to IT. You often need to strike a dynamic balance between accessibility, security, and reliability. The existing protocols have some valuable features for these challenges, but none of them alone is ideal for moving OT data to IT or the cloud. With Cogent DataHub software and services, you can bridge that gap and be fully equipped to meet the challenges of providing secure, reliable access to your operational data.